So let's look at this function. So for example, this function looks like this, let's say, right? And you have taken a point, let's say x naught here. I want to see whether it is continuous or not. Don't tell me that you can write this function without lifting the pen and all that. Well, maybe from a practical standpoint, yes, but what is the proper definition of a continuous function? Huh? Check the limits. Limit of what? No, I know how to take the limit of a sequence, right? I know a convergence of a sequence, but I don't know what is the limit of a function, right? What can you say about this? So now what I can do is I can suppose x naught is a see I know how to I know how what is a sequence and how what do you mean by convergence of a sequence. Now I have to somehow convert this whole notion into a sequence, right? What do I do? What do you mean by limit of left and right? Oh, okay. So in the interest of time, maybe I'll okay, maybe I think I should let you speak. Yeah. Okay. So essentially, you take any sequence xn that converges to x. Okay. Take any sequence xn converging to x naught. Well, xn is in R, so we don't have to worry about whether f of xn is defined or not. So it's entire R. That's how I'm defining. You take any xn that converges to x. Okay. If f of xn, so what can you say about f of xn? F of xn, x1 is a number, f of x2 is a number, f of x3 is a number. So it's a sequence, right? Now, if f of xn converges to f of x naught, right? So no matter what sequence xn you take that converges to x naught, we say that the sequence, the function is continuous at x naught. Okay. Can you write the definition of the continuity of a function? So definition, I'll leave it. Okay. Continuity at x naught. But what do you mean by continuous function? This is only continuity at x naught. But if it is continuous at every point, right, then we say that it's a continuous function, right? So one more small jargon. So the thing that get mapped to is called domain of a function. Okay, this is another jargon. This is called range. You know that, right? It's very clear. It maps to something, that's the range, right? This is the domain. Okay, this is just another name. Everything clear? Okay. So now, okay, so what is the next step? Suppose example, not example, it's problems. So if you take two functions, okay, f and g, well, I won't write f of x, g of x, okay, f and g means f of x and g of x, or two functions, two continuous functions, then what can you say about f plus g? If two functions are continuous, intuitively, the sum also you should be able to write without lifting the pen, right? So intuitively it is a continuous function. Some alpha f, that is, you take f of x, you take 100 f of x, 100 times f of x. That's also a continuous function, right? F by g, is this a continuous function? Huh? Is continuous if g is not equal to 0 for all x, right? If, okay, let me write this as a condition. G of x not equal to 0 for every x. Okay. What else? What about f times g? It is, right? Product of two functions. Okay. So, well, this would be an exercise, but how do you prove the product? Suppose you have proved everything else. How do you prove product? Okay, one more thing I'm going to add here. Okay, so maybe I'll add it here. Let me call this as 1 dash. F squared, what can you say about f squared? If f is continuous, f squared is also continuous. Now, can you put everything together and prove that f times g is continuous? See, first thing says f plus g is continuous. right? The second thing says that if a function is continuous, square is continuous. Can you complete the proof now?
Yes,
If
sir.
f is g is continuous, minus g is also continuous because alpha g, right? So now f minus g is continuous, whole squared is continuous. What should I do? I should add then again alpha, right? Right? Easy proof. That's why I completed the proof for this, but the remaining or it requires a little more effort. Okay, but you should remember this anyway. This will be part of your homework problems. You will try to prove some of these. Okay, fine.